Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so this problem, the setup that we have, or the situation that we have, is a long straight wire that is placed in an external magnetic field. This magnetic field has no relation to the wire, meaning it's not created by the wire. It's from something else that we don't know. It's just there. This wire is in this field. And we know from our extensive research on magnetic fields that the wire with a current in it will produce a magnetic field. So we have this external magnetic field that is perpendicular to the wire, or perpendicular to the current traveling in the wire. And we are tasked with finding the net magnetic field where it's equal to 0. So B net we want to find where B net is equal to 0. So first we need to understand what that means exactly. So now the wire here is going to have its own magnetic field that moves around this way. So we need to find the points where the magnetic field from the wire cancels with the magnetic field from this external force, or this external whatever is creating it. So if we take a point here, this point is still going to have the magnetic field I have in green pushing it up if it's a charge, and it will have the magnetic field from the wire pushing it down. So we need to find what this distance is from the wire. And we have an equation for what the magnetic field from a wire looks like. So the magnetic field created by a current carrying wire is equal to mu naught, the constant, times the current in the wire, divided by 2 pi times the distance, or the radius, from the wire. Times the radius. So that's our equation for the magnetic field from the wire. Now everything that we have in this equation, we're given I, we're given the current, we're given the magnetic field of this external force, the green B here, we're given that, and we want to find the distance, which is this R, because the magnetic field travels in a circular path around the wire. That's why it's called R. So if we have a circle that goes around the wire, the distance from the radius, which is the center of the radius, which is the wire, to the edge of the circle is what our R is going to be. So in this case, we'll have a big circle that goes up to this point here, my reference point. So that will be our R, which is this distance. So we want to find where the magnetic field cancels this external magnetic field. And by doing that, if we set this equation equal to this magnetic field from this external magnetic field, we'll find where the force from the wire is equal to that. And then we just have to find the point where it's in the opposite direction, which we don't know anything about direction, so we just need this distance R. So when this B is equal to the external field, it will completely cancel it out. So we can use the same B and just plug it into this equation. So that means the only unknown we have here is R. So we can solve for R. Rearranging the equation with some simple algebra, we get R is equal to mu naught times the current divided by 2 pi. Basically, the R and the B are going to change places. Divided by B, which is the B of the magnitude of the external field. It will be the same at this point for the wire and for the external field. So the same number B you'll use here. And this will give you what radius you'll need at that point. The magnetic field will be equal to 0. And there you have it.